Assalamualaikum and a very good day to all of you. My name is Amin Umira binti Muhammad Nazir. I'm a PhD student for Faculty of Earth Science from University Malaysia Kelantan, and my research is about the effect of monsoonal periods towards nighttime ground level ozone in East Coast Malaysia. So before I explain deeper, so what should we know about the ground level ozone? Ground level ozone is actually classified as secondary pollutant where its formation and destruction highly depending on sunlight and nitrogen oxide. As Ramli says that the concentration of ozone actually in nighttime and early morning should be expected to be low, and as there's no sunlight enhanced. So this is where I'm looking the whole process of how the ozone produced and how the ozone disrupt during nighttime. In daytime, nitrogen dioxide, which is produced from the vehicle incomplete combustion of vehicle, interact with the sunlight. It produces the nitrogen oxides molecule with oxide molecule. So oxide will interact with oxygen and producing the ozone. That's how ozone occur in the daytime. While in nighttime, there should be the ozone destruction where is nitrogen oxides interact back with the ozone existing in air, producing back nitrogen dioxide with oxygen. Is stated by the Kulkarni and other researchers with the few. So, actually, numerous studies stated that ground level ozone during daytime give a negative impact either to human or vegetation as well as the environment. The effect of ground level ozone actually can be contributed by the topographic conditions, seasonal variation, and geographical location. So what am I looking is the monsoonal contribution to the ozone. So I'm looking for the seasonal variation. So as I'm seeing that it should what other researchers looking at and observing is high ozone concentration only detected during daytime, and then it should be continue gradually decrease during the evening, and constantly decreasing in nighttime as there is no photochemical reaction occur due to the absence of the sunlight. And what I'm looking is either meteorological condition be the one of affecting the ozone destruction during nighttime. So, as other researchers, as Chen stated that the temperature was the key influencing ozone concentration, was supported by relative humidity and wind speed. So I'm gonna use temperature, relative humidity, and wind speeds as three parameter representative to the monsoonal period. Actually, while I'm looking at the East Coast region, the daily average rain fall in East Coast region uh, was not influence the nocturnal ozone concentration in Malaysia, but can be translated to low ozone production, as be said by the Jamaluddin. Therefore, I'm focusing in order to have a better understanding of nighttime ozone variation and its trend during the East Coast monsoonal period. So, study area for my research is at East Coast Peninsula Malaysia, which is Kemaman, Terengganu, stated as industrial, and Kota Baharu, which is urban. So I'm getting the data from the Air Quality Division of the Department of Environment, Ministry of Natural Resources and Environment of Malaysia for 6 parameter, which is ozone, nitrogen oxide, nitrogen dioxide, temperature, humidity, and wind speed. And I'm selecting for the January to March and October to December as a representative the monsoonal period. So, as I'm looking for the nighttime ground level ozone for hourly data, I'm looking for 7 p.m. to 7 a.m. So, the three analysis data that I'm looking is descriptive analysis, diurnal plot, and percent correlation. The uh, the picture below, the figure below, showing the location of Kota Baharu and Kemaman in Peninsula Malaysia. So, the results that I'm getting for descriptive analysis, it shows that the nighttime ozone concentration in Kemaman, Terengganu throughout the four monitoring years of from 208 until 2008 until 2011 was generally low. As you can see, the mean value actually 17 and 9 ppb. Uh, but for NO and NO2 concentration show a similar condition as directly proportional to the each other in both location. The mean for both Kemaman and Kota Baharu was considerably low. Um, Actually, there was a researchers, there was Awang and Ramli already said that the depletion of ozone during nighttime was due to NO titration and deposition process. So that's what I'm looking at. So from this descriptive analysis, as we can see that even though the highest maximum ozone concentration was 65 ppb, but it not exceeded the recommended Malaysia air quality guideline of 100 ppb. It same goes to the NO and NO2 concentration for both location, which not exceeded the recommended Malaysia air quality guideline with 170 ppb. For NO2, actually the descriptive analysis is to see the minimum, maximum, mean, and standard deviation for the overall data that I'm selected. So I'm looking for diurnal analysis. The other why I'm looking diurnal analysis, and the diurnal plot actually was produced to monitor the pattern of ozone and its progression throughout the average concentration of hourly. And the diurnal variation of ozone concentration was made to elaborate the pattern, and it was controlled by a few process, which is photochemistry, physical and chemical removal, deposition, and transport rate. So, for diurnal analysis that I'm getting from this study, in both of the location undergoes the same pattern of ozone concentration, and it start increase at 8 a.m. and decrease obviously after the sunset. For ozone concentration that stated for both locations stated low and constant during nighttime, it was similar to the finding of the ghost in Kolkata, India. Ozone concent even though ozone concentration is low, uh, and not exceeded the recommended air quality guideline, ozone still the comparison between the location ozone concentration in Kemaman show a bit higher than the Kota Baharu either in daytime or nighttime. For NO and O2 concentration in Kota Baharu, it display higher during nighttime compared to the Kemaman. The diurnal pattern in Kota Baharu, it have interesting two peaks concentration for NO and O2 concentration, as you can see from the graph. And for the pattern of the temperature, and it shows that the highest percentage of relative humidity is 100%. So um, it has a high uh, percentage of the relative humidity for both location, and moderate condition for average temperature with for both location with 24 and 26 degrees Celsius, like that. That's the pattern for both location. So I'm looking to the relationship between ozone and its precursor, which NO and O2, and temperature, RH, and wind speeds. So it can be said that The correlation of ozone with the relative show the vice versa of temperature for both location. So if the temperature have a negative correlation, and then it goes to the uh, it goes to the temperature for the Kota Baharu, it has a positive correlation. Actually, according to Punitabi, the temperature can significantly affect the ozone concentration with high positive correlation, but this study showed the different result as the Kemaman exhibit lower negative correlation. So for the wind speeds, it have a positive correlation in both location, which indicate that wind has become a factor that induce ozone formation as ozone was transported to the monitoring area. So as I can conclude is Kemaman and Kota Baharu show the lower concentration of ozone with ozone, and the diurnal cycle for ozone, nitrogen dioxide, temperature, RS, and wind speed was similar for both location. But Kota Baharu have two peak concentration of NO and O2 NO2 NO2. And for it can be said that Kemaman had a negative correlation for temperature and ozone, while a positive correlation for relative humidity. Meanwhile, for Kota Baharu, it showed that positive correlation for temperature and negative correlation for relative humidity. And from all the finding, it can be shown that NO2, temperature, RH, and wind speed was not the only factor influence the ozone depletion during nighttime, as the correlation display was lower. This was the list of my reference, and that's all. Thank you, and Assalamualaikum.